Hello again. We are going to solve this problem together. So I have three equations of three planes, and I want to find if they are intersecting, which case we have. I look at the three equations. I found that neither normal vectors are scalar multiples, nor any equation is a multiple of the other. So like the previous example, it is either case 1 when they intersect in a point, or case 2 where they intersect in a line, or case 5 where each of which these two planes intersect in a line, these two intersect in a line, and these two intersect in a line. And in this case, no solution, and we just write inconsistent system, no solution. So we need to know which case is that. As I showed you, we are going to use matrices to solve this. The reason I want you to learn it this way is matrices and the way we did cross product is a big branch of math called linear algebra. And anybody who's going to study math in university, you need to do that. So you can consider this introduction to linear algebra. So I will write the first row. So 2 minus 1, 1 and 1, 3, negative 5, 4, 3, 3, 2, negative 1 and 0. As I told you, our target is to make this triangle 0, and starting in this order, 0, then 0, then 0 here. So we need to have, the first thing, we need to have a 0 in this instead of this 3. So I'm not going to change anything in the first or the third row, so I write them as they are so I don't get confused. Then the only change will happen in the second row. What is the least common multiple here? It is 6, so I will multiply this row by negative 3 and this row by 2 and 8. So negative 3 times 2 plus 2 times 3 is negative 6 plus 6, so that's 0. Negative 3 times 1 is 3. 2 times negative 5 is negative 10. So I have 3 minus 10, that's negative 7. 3 minus 10 is negative 7. Negative 3 times 1 is negative 3, and 2 times 4 is 8. So negative 3 plus 8, that is negative 3 plus 8 is 5. Then the last thing, negative 3 plus 6 is 3. Okay, so that's what we get in the second row now. Now, what we are going to do is we need to have a 0 here. So I will use the first row because I cannot use this row to make this 0 because I have a 0 here. So I cannot multiply this by any number to have a 3. So I have to use the first row. So the same thing I did, I will multiply this by negative 3 and this by 2 and add. So I'm not going to change anything in the first or the second row. So I write them first and let them out of the way. The only change will happen in the third row now. So 0, 3 and 4 is 7. Negative 3 and negative 2 is negative 5. Negative 3 times negative, that's negative 3 and 0, so negative 3. Okay, now we succeeded to make these two zeros, and we need to have a 0 here. So I cannot use this row again because if I use it, I will ruin the 0 that I suffered to make. So I will use the second row. So nothing gonna change now in the first or the second row. I will write them first. 0, negative 7, 5, 3, 0, 7, negative 5, negative 3. Now, what? Oh, I always like, I am working to make this 0. So now we are going to find the third row. What would I do to make this 0 using the second row? If I just add, I will have a 0 because negative 7 plus 7 is 0, so I don't need to multiply by anything. So 0 plus 0 is 0, negative 7 plus 7 is 0, 5 plus 0, negative 5 is 0, 3 plus negative 3 is 0. So the last row was all zeros. What that tells me, from here I can tell that 0z equals 0. What does that mean? What is the value I can use for z to multiply to 0 and I get a 0? Any value. So that means we have infinite solution. So which case is this? Is it this case? Is this has infinite solution? Or this case? Or this case? This case has infinite solution because all the points on the line are are common in the three planes. So it is case 2, line of intersection. Now our target is to find the equation of that line of intersection. 0z equals 0, that means I can say let z can be anything. So let's make it t. So we get z with the in terms of a parameter t. Now I'm going to the one above equation. So negative 7y plus 5z equal 3. And instead of z, I will put what it equals now. It is t. So I will solve for y. So from here, 3 minus 5y. So y will equal, okay, I will send the 7 over here. Okay. Anyway, negative 3 over 7 plus 5 over 7t. So I send the 5t to the other side, so it will be minus. Then I divide it by negative 7, so I get negative 3 over 7 and set 5 over 7. So this is the y. Okay, now I can get the x using this equation. So 2x minus y is this, so plus 3 over 7 minus 5 over 7t plus t equals 1. Now I will combine the t and the 7. This is 7 over 7, so 2x will equal, this is 5 over 7 and 7 over 7, so that leaves 2 over 7. So when we send it to the other side, it will be negative 2 over 7. 7 over 7 is the same as 1. So in the negative, this will be positive 2 over 7 from here. I send it to the other side as negative. And 1 take away 3 over 7, that will be 4 over 7. So negative 2 over 7t. Okay, I'm just doing algebra. So now x equal, divide by 2. So 2 over 7 minus 1 over 7t. And this is the parametric equation of this line of intersection. If you want to write it in vector form, you can. So r sub 0, which is 2 over 7, negative 3 over 7, comma 1. the equation that represent the solution where these three planes intersect. Case number 2. Okay, I want to tell you what case number 5 will be. We are going, so let me erase everything. So now we know when it will be case number 1 or case number 2, how case number 5 will look like. It will look like something like this. You're gonna do all the, let's say the last matrix we get was like this, 2, 3, 4, 1, 0, 5, 7, 2, 0, 0, 0, 5. Okay, we did the same steps. Assume, instead of like having another example because the time is limited. So assume that we did all the matrices and we get a 0 here, 0 here, and 0 here. We ended up with this row. So when I write this equation, I will write 0z equal 5. Can I find the number? I multiply it by 0 and get 5? No. So no solution, and this will be the Lavache-Curie case. Each couple of planes intersect in a line, but the three has nothing in common. So no solution, inconsistent system. If you ended up with 0, z equal a number. Okay, this is how this case will be. Alright, so we have learned a very important lesson, and you must practice those. Things may look easy when I do it, but when you do it, maybe you will find some difficulty, so you need some experience. I will give you some examples to do, not too many, and send me your questions. Okay, we are almost there, guys, or we almost done. Okay, have a wonderful